Alright, Crewton Ramone's House of Math. Another addendum to this. Okay, you need to watch the other one about putting it in terms of X and H. Video, find it. Should be underneath here. Hopefully, if I'm that organized. But a couple of things. Alright, so literally in terms of, we're talking about putting this triangle in terms of X and H. So here it is in terms of X, obviously, and here it is in terms of H. Look, I'm in color code on everything, right? So it's in terms of H. And how do I know what H is? Well, because I know that the hypotenuse is 2 times X. And so this is in terms, actually, of everything in relation to this one side, when you get right down to it. Right? The ratio of 1 to square root 3 to 2 is what this is talking about. If you want to get into data, get into analysis, as they say. Because really, the fun thing about mathematics is you can take it down to the nth degree if you want to spend enough time fooling around with it. Okay, so there it is. So there it is. Those are the 2 ways we're going to express this triangle. So this is in terms of H. So if it's in terms of H, literally, I just plug it in 1/2 base times height in my formula. If it's in terms of X, there it is. And this was the question, actually, that I didn't get to. So I'm making a whole another video to address this one simple question. How come it's 2 there and 8 there? That was the question. Okay, so here all I've done is I've taken my X, right, times this, length times width, and taken half of it. That's literally what that is. Length times width and a half of it. Because that's all that is length times width and a half of it. Got to look at it. The most basic thing where you make rectangles to facilitate counting. And that formula makes a rectangle out of any triangle. Okay, so then I just take that. Okay, but over here, when I take, because it's in terms of H, and I had to cut my H in half over here, and I had to cut my this side in half to make this 1, because I don't want I could make this a different number, but I want it to be 1. I want it to be in terms of 1 hypotenuse, just the length of that hypotenuse. So here, if I have the rest of the triangle in terms of the length of the hypotenuse, as opposed to in terms of length of this side, then this is H. This will have to be H over 2, and this square root of 3, because of Pythagoras, is got to be the square root of 3 times H divided by 2, that side, because these are how we're going to define this triangle. And then again, you need to understand the very basic concept of a squared plus b squared equals c squared, and it does apply, but I'm not putting it in here, just like I'm not putting the 30, 60, 90 numbers in here, because it's not relevant to our problem. Dicta. So once I have this side is h over 2, and this side is, I know that this is h over 2 in terms of the hypotenuse there, then I just put it in there for my other side, and then I stick it in there, and I got a whole bunch of 2's, right? That my one side is now divided by 2, and this other side is divided by 2, and then when I multiply all of it by a half, it's 2 times 2 times 2, which gives me the 8, right? I mean, I could, if I wanted to get fancy, I could put, 2 cubed down here if I wanted to, but that wouldn't help. Fewest symbols possible to get the greatest, right? That's actually extra symbols to get the most idea across. That's called the economy of simple. Simple as that. So we keep it simple that way. Okay, so there it is. Basically, that's why that's 2 and that's 8. And then another thing that one student was doing was taking somehow thinking that you had to take this times that and everybody over 2, and then it would get really confusing. So rather than do that, because technically that's true, that's what we're doing here, why not just multiply by a half? Keep your thinking simple. You know what I'm saying? Because what the student was getting confused with is that they were dividing this by 2 and dividing that, and then they got confused. Because it's true, it is. If I could rewrite that as base times height all over 2. So if I put this is my base and this is my height, and I could put that all over 2. But man, isn't it a whole lot easier to just multiply by a half? which is the same thing as dividing by 2. Okay, I hope that clears up all the questions that I can think of that the students had. Anyway, we're putting one thing in terms of another and making sure that if it's no fun, we make sure to get back to 1. I want to know about 1h, and over here I want to know about 1x, right? So in this triangle, if you get right down to it, we're talking about this side as our point of reference. In this triangle, we're talking about this side as our point of reference, our hypotenuse as a point of reference, as opposed to one leg as the point of reference. And there it is when we actually use numbers, and we're not just out here in the ether of algebra where we're using general terms for every triangle. Right? This is one very specific triangle where we have one side is 1, the hypotenuse is 2, and that is square root of 3 for that other leg. But what we have here is any triangle. We can put any numbers in now. We can put any numbers in now for both of these. And now we can describe all triangles that are 30, 60, 90 in terms of either the hypotenuse or x, or the one side. Okay, that's probably more than you need. I would hope that that would be far more than you would ever want or need on this problem. And then the other thing is, do the other special triangle and do the same thing where it's 1, 1, square root 2. Right? This triangle right here. In case you somehow manage to forget the other special triangle, which you're going to be having to learn a lot about here very shortly when it comes to the unit circle. Okay, so anyway, okay, so now do that one in terms of h. Right? Now it's going to get really interesting. It's a more complicated problem, actually, but not by much. It's the same thing. You're just going to use half base times height, and anyway, that's it. That's as much as I'm going to give you. Anyway, do the same problem, right, where we express it in terms of the hypotenuse for that triangle. All right, Crewton Ramone's houseofmath.com for more.